Welcome everyone. In this video we will solve a very interesting physics question, an Olympiad question about equilibrium. Let me draw the picture and then it will be much easier to explain the question. So we have a ground. Oops. I was on black, excuse me. We are on a ground and there will be Q1 charge at a distance of 8r from this charge. There is a charge Q2 and this Q2 charge has a mass m. The gravity is downwards. Okay, and by the way, this is a Turkish physics Olympiad question. I will attach the original paper in the descriptions part so you can have a look at it if you know Turkish. And there is another system given. We have two systems. It makes it even more interesting. We have Q1. This is a ring of uniform charge and the total charge is Q1. Along its axis, there is the same Q2 with its mass m. And this distance, the radius of the ring is r. What else? And also, this is connected to a string. There is a rope with length L. Now, we're asked the question, what is L in terms of R? This is the question. And in the second picture, gravity is like this. Now, we're told that both of these systems are in equilibrium. So, Q2 here and Q2 here, they are both in equilibrium. With that being said, what is L in terms of R? Why don't you pause the video, try to do it on your own, and when you're ready, continue the video and let's do it together. Alright, I assume that you're ready to see the solution, to solve it together. Now, how do we start? Well, the best way to start is to consider what equilibrium means. Equilibrium simply means that for these purposes, there is not rotation, there is no need to consider torque. For these purposes, we're basically saying that F net on the second charge is equal to 0. So let's use this idea for the first system. What are the forces on this guy, on Q2? Well, there is mg downwards, of course, and upwards there is an electric force, Fe, let's call it, okay? Force of electrostatic force, electrostatic attraction. Repulsion in this case, but yeah. So these two need to be equal to one another so that the net force will be equal to 0. So mg, the weight of the charge, is balanced by the electric force between the two, electrostatic force between the two charges. And how do we find that force? Well, using Coulomb's law. It is Coulomb's constant times the first charge times the second charge divided by the square of the distance between them. What is 8r squared? It is 64r squared. Cool. This is all the information that we can gather from the first system. So now let's move on to the second system. For the second system, let's draw a free body diagram of the second charge. We have mg downwards, again, that didn't change. And in the rope, there will be a tension. That tension is along the rope and it is pulling Q2. Let's say that this angle is theta. And of course, Q1 will be pushing Q2. It will push it completely horizontal because Q2 is sitting sitting along the center, right? It is in that direction. It is on top of the center, you can say, if you look sideways if you look to the picture sideways. So the force is completely horizontal, Fe. Now this is going to be a different electrical force, electrostatic force. It will be different than the first case, and we will figure out what it will be. So how do we figure out this electrostatic attraction though? Well, to do it, I would consider a charge of dq on the ring, and I would try to come up with the infinitesimal force that acts on Q2 because of this dq charge. So the infinitesimal force, the electrostatic force, would be, well, we would have K, the Coulomb constant, Q2 dq, divided by the distance between the two. Now, what is the distance between them? It will be L squared, right? And if we take the integral on both sides, we will notice that everything is constant for this integral. L is constant for any point on the ring, so we can basically take the integral of dq, which will give us q, the total charge, which is q1. So this is a very easy integral. In fact, we get that Fe equals, for the second case, right? It is, let's even do it like this. So this was Fe1 and this is Fe2, all right? Let's be even more precise in our answers. So Fe, the electrostatic force in the second picture, is going to be K, Q1, Q2 divided by L squared. Right? I mean, is this it? Well, you might be saying, all right, this is it. But actually, there is a very important thing that we forgot to do here. And that is, notice this. If this point pushes it like this, then this point will push it like this. So the vertical components will cancel out. Only the horizontal ones will remain. So to get the horizontal ones, since we called this angle as theta, we will need to have cosine of theta here. Okay, this is perhaps the trickiest part. We need this cosine of theta, otherwise we're neglecting the fact that the vertical components cancel. We only want the horizontal components. All right, I hope this one makes sense. It is quite important that it does make sense. Cool. So we can now use the free body diagram to write force equations. Considering the horizontal, we see that this attraction is also equal to, this repulsion is also equal to T times cosine of theta. So it turns out that the tension in the rope is equal to K times Q1, Q2 over L squared. All right, cool. Now, considering the vertical direction, we see that T sine of theta equals mg. So let's just substitute for T and mg. What is T? We just found it. It is K, Q1, Q2, L squared times, we need sine of theta. And what would that be? Well, here is R, here is 90 degrees, here is L. So sine of theta is R over L, right? Just look at this right triangle. Sine of theta is opposite over hypotenuse, so it is R over L. And this equals mg right here. So K, Q1, Q2 divided by 64R squared. And we see that all of these guys cancel. If we make this look prettier, you can see that this gives us 64R cubed equals L cubed. If we take the cube root on both sides, we get that L is equal to, now which number gives 64 when it is cubed? That number would be 4. So L is equal to 4R, and this is it. I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.